Welcome to another awesome coding day in Nuremberg, Germany. Today I talk about scopes and it will be confusingly funny or funnily confusing, I don't know. Let's jump right into it. So I just defined my void function. So first question is, what scope is the function main? So it has a scope file, so it is file scope, because it can be seen, inside this file only. Okay, so let's define some variables, a and b. So what scope do they have? Those variables can only be seen inside this block here, inside those brackets. So it's called block scope. Let's define them. Okay. Cool. Works as expected, so nothing new here. Now it starts to get weird. So we define another block inside our block. Therefore, we use brackets and just put the stuff inside. So question is, what happens? Do we get an error? Do we see 1 and 2, or do we see 3 and 4? And the answer is we see 3 and 4. So let's have a deeper look. Let's print out a and b inside the block before we define a and b. What happens? Do we get an error? No, that works. So we created 1 and 2 here and print them out. And inside this block, those variables are still valid as defined before. But we can create an overlay by defining a and b. And then this overlay will be valid inside this block. Outside this block, it will be 1 and 2 again. So we can print it out. And you see, a and b is 1 and 2 again. That's the last printf statement. So let's make it a bit more weird, because we can have nested blocks. And I think you expect already the right thing to happen. So let's make it a bit more explicit. Nested squared. And let's call this nested. So we see 1 and 2 as expected. Then we have our nested print statements. That's cool. And oh, I forgot to set new values here. And then we learn that this printf statement makes use of this overlay here. It doesn't make use of the top definition, so to speak. It makes use of the nested definition, but feels about right, doesn't it? Of course, we can create another overlay. And when we leave those brackets here, actually, we can print it out here too. So this is nested again. Then we will see 5 and 6. So this is this print statement here, and then we execute this one here, and this is just 3 and 4, like defined in this overlay. And then the last print statement is just inside the general block here. So it will be 1 and 2 again. I hope that makes sense. So, but we can make much worse, of course. We can define integer a as global variable. Let's say -1, h is -2. So we should print out a and b before we define them here. So what do you expect? So most of you will say probably we will see -1 and -2, and that's correct. Okay, those variables are defined outside the function, so they have file scope. They're accessible inside this file. They are also accessible outside this file via the extern command, and that's why we generally should use static in front of them, but that's not the topic of this video. Okay, now let's define our stupid function. And print out a and b. So let's call my function and call it with 10 and 11. So what do you think? When we print out this nested squared statement here, I think we should make it easier right now. It's just, let's do it. Embrace the confusion. Embrace the confusion. So what do you think happens? So when we print here, do we see 5 and 6, or do we see 10 and 11? So let's try it out. And we see my function. Oops. So we see inside my function, the values are 10 and 11. So when we call this function, we get this print statement. But the next print statement, nested square, gives us 5 and 6. So those variables are only valid inside this block. So the variables have block scope, but my function has file scope because it's outside of a function. So it's just visible by any command inside this file. Okay, now we can do one thing more. In C, actually, it's common to use the goto statement for cleaning up allocated memory. So let's say free memory. And this is just, let's print out A and B. And this is just a name, basically for this line here, and we can go to this line from anywhere inside the function. So we can now say go to free memory, and what happens now? It prints A and B, which is 1 and 2. That's what we see here on the right. But then it goes to free memory, jumps over all those blocks directly to free memory, and prints free memory. That's what we see here. Okay, so the point is we can put this thing in a block 2 and it still works the same way. That means it's not block scope, it's also not file scope. What we have here, that's called function scope. It's visible inside the entire function, and it's only relevant to these go-to things. Now we can, let's say, go to free memory from inside this block, and we jump right into another block. And we see it's 1 and 2. So now we come to the fourth type of scope, and this is the rarest type. And it's a function prototype, like so. You remember a forward declaration, like we just said, there is this data type, and I don't find it here yet, but I will do somewhere. This is very similar. So we just inform the compiler that there is a function, integer add, and it takes over 2 variables, and those 2 variables are only valid inside this definition here, so they exist only here. And that is why, so when we later define the function, we write again integer a, integer b, and then those variables will be valid inside the block. But in this special case, when we just write down the function prototype, then it's called a function prototype scope. And is it of great use, or is it an important information? Not so much, but what you can do here actually is you can leave away the variable names. This is not so good in my opinion, because you should inform other programmers about the variable names, but actually this is valid C code. So when we do this, we have to define this function too, like integer add and we might also return a plus b. So I forgot the integer. So you see that works, but we didn't use add, so nothing to see here. And those variables here have again a block scope. They are valid inside this block. So after all those print statements and those variable definitions of A and B, I hope you understood it, and stay awesome. See you soon. Ciao.